Now let us see the example number 3, and which is application of Lamis theorem. So three forces of magnitudes P, Q are acting on a particle is in equilibrium, and the angle between P and Q is double than the angle between P and R. Then prove that R square is equal to Q into inside the bracket Q minus P. So for this purpose, we have to draw the diagram of these three forces acting at point O. So this is a force P, this is Q, this is R acting at one point, and according to given thing, the angle between P and Q is double than the P and R. Therefore, we are considering the angle between P and R is theta. Therefore, the angle between P and Q is twice, means 2 theta. And we know that the total angle of the circle is 360, that means 2 pi. So this is theta, this is 2 pi. Therefore, this two angles addition is 3 theta. And therefore, the remaining angle, this angle is nothing but 360 minus 3 theta. That means 2 pi minus 3 theta. So now I am writing the solution. So first of all, give the all information which you are observing in the figure. So let P bar, Q bar, R bar be the forces, acting at point O. Okay. Now let the angle between this P and R is equal to theta. Therefore, the angle between P and Q is according to given thing, it is equal to 2 theta, and therefore the angle between this R and Q is equal to 2 pi minus 3 theta. Now three forces are equilibrium acting at a point, and we know the angle between them, so we can use what? Lamis theorem. So now we are writing by Lamis theorem. We can write like this by Lamis theorem. What is Lamis theorem state? The P divided by sine of angle between Q and R other than P is equal to Q upon sine of angle between P and R, means other than Q, and it is equal to R upon sine of angle between P and Q. We know all the angles, therefore it can be written as P upon sine of angle between Q and R. Q and R is 2 pi minus 3 theta, okay, is equal to Q upon sine of angle between P and R, that is the theta, and this is equal to R upon sine of angle between P and Q, that is 2 theta. Now in the first ratio, the denominator having a compound angle, and the first angle is a integer multiple of pi. So this is a subject family, and due to the multiple of pi, sine remains as a sine. So that's why its answer is sine of 3 theta. The 2 pi minus 3 theta, that means if you draw the quadrant, and this is 1 pi, this is 2 pi, and minus 3 theta means you are something here in the fourth quadrant, and we know that in fourth quadrant cos is positive, you are finding the sine, therefore the value of this is what? Negative. And therefore in the next that is P upon minus sine of 3 theta is equal to Q upon sine of theta is equal to R upon sine of what? 2 theta. Now if you observe the denominator, all are the ratios are sine, but the angles are different. One is theta, another is 2 theta, and third one is 3 theta. So for the simplicity, we have to convert the denominator in a single angle. That's why we decided to use this formula. The sine 2 theta is equal to, the half angle formula is 2 sine theta cos theta, I will use here, and sine of 3 theta is equal to 3 sine theta minus 4 sine cube theta This is the formula of sine 3 theta. I will use this here, and therefore the above ratios will become as P upon minus, we can take sine theta as a common, so sine theta, this is a 3 minus 4 sine square theta, alright, it is equal to Q upon sine theta, we are keeping this as it is equal to R upon, this is 2 sine theta into cos theta. Now this sine theta, and this sine theta get cancelled. Therefore, we are getting P upon minus, that is 3 minus 4 sine square theta is equal to Q upon 1 is equal to R upon 2 cos theta. Now, the middle ratio does not involve any trigonometric ratio. Therefore, I am considering this second and third ratio. I am getting the value of that is 2 cos theta into Q is equal to R, and this implies cos theta is equal to R upon 2Q. Okay, so keep remember this value cos theta. We can use this value in further calculation. Now I will consider first ratio and second ratio, and using these two ratios I will find the value of sine square theta. All right, so Q, that is P upon, the first ratio is P upon 3 minus 4 sine square theta is equal to minus Q. This minus sign transfer to this side, and therefore this can be written as P is equal to minus Q into 3 minus 4 sine square theta. All right, so now this is P upon minus Q minus 3 is equal to minus 4 sine square theta. All right, now dividing minus 4 to this side, I'll get P upon 4Q plus 3 upon 4 is equal to sine square theta. All right, and then in the back slide we have taken this value cos theta is equal to R upon 2Q. So now here the cos theta is equal to R upon 2Q, and this implies cos square theta is equal to R square upon 4 upon 4, R square upon 4 into Q square. Okay, now this is a sine square theta, this is a cos square theta. We know that sine square theta plus cos square theta is equal to 1. This is the fundamental identity of trigonometry. Now here I will put this is a sine square theta, so this is a sine theta square plus cos theta square is equal to 1. Now I'll put value of sine square theta this one and value of cos square theta this one. So this implies, I think this is a P upon 4Q plus 3 upon 4. This is the value of sine square theta plus R square upon 4Q square is equal to 1. Now this denominator is a 4Q, so I will multiply by Q in the numerator and denominator. I will multiply by Q square in the numerator and denominator, so that the denominator of three fractions will become same. So now it is common denominator, that is 4Q square, and this is a PQ plus 3Q square plus R square is equal to 1. Now this PQ plus 3Q square plus R square, now I can write this equation as PQ plus 3Q square plus R square is equal to 4Q square. Alright, and therefore the value of R square is equal to, transfer this 3Q square to this side, 4Q square minus 3Q square is Q square, and this is a minus PQ. Now therefore r square is equal to q taken as a common, so it is q minus p, and this is our required result.